back again. We're going to look at the glancing angle and the angle of deviation. First, we looked at the angle of incidence and the angle of reflection. Now let's look at two more other angles. When you look at G from the mirror M naught and then to the line OA, and then when you look at D, it's from A prime and then B. When you look at those angles, one is called angle of deviation, another one is called the glancing angle. When you look at the angle or the angle G, this is the angle, the glancing angle. The angle between the incident ray and the reflecting surface. Always the glancing angle is between the incident ray and then the reflecting surface. Then when you look at that angle, or when you look at that line of incidence or the incident ray, you see it is traced backwards, then where there is A prime or A to power 1. So here they are imagining, assuming this mirror was not there, the direction of the light was to go straight through out. But because of the reflecting surface, that's when it changed its direction. That one gives us a word deviation. It deviated from this original path A to power 1 to the path OB. Then the angle between this line, which this ray was supposed to take, up to where it took, or up to where the ray reflection is, that is what we call the angle of deviation. So in definition, it is the angle between the initial direction of the incident ray and the reflected ray. That ray is extended, or the extended incident ray. So it is represented by letter D, small d. So D equals to the angle A prime O and then B. Oh, that thing represented by that arrow, that is what we call the angle of deviation. Then we want to calculate and see the relationship between the angle of deviation and then the glancing angle. So D is equal to G, because this one, the angle between this ray and the surface is the glancing angle, that is G, plus angle M naught O and then B. You seeing that? But angle M naught and B and O and B is the same as 90 degrees minus R from mathematics. That is 90 minus R. But from the laws of reflection of light, R is equal to I. Therefore, where there is R, instead we represent with I. That one brings to us D equals to G plus, in brackets, 90 minus I. But 90 minus I